questions 21 to 25 on the 2005 Grade 11 Fermat Math Contest. 4 different numbers, A, B, C, and D, are chosen from the list -1 to -5. The largest possible value for the expression a to the power of b plus c to the power of d is. So this is what is known as a trial and error question, but the good news is that you don't have to go through every single possible combination because that would take forever. There is some logic, some rhyme or reason to how you will approach this. The first thing that's important is that they want the largest, right? So we want to try to get positive numbers. So, for example, if you were to choose -1, and that is your A, and then for B, let's say I chose -3. Well, this gives me 1 over -1 to the power of 3, and that's 1 over -1. That's a negative number. And I'm not going to get the largest possible value with negative numbers. So I've got to make these positive. So if I choose A, let's say I choose A to be -1, I've got to ensure that the B is an even number, either -2 or -4. That's the only way that we're going to end up with a positive number, right? Because watch what happens. You got -1 to the power of 2, and this becomes 1 over 1, which is, of course, just 1. All right? So that's the first part of that question. Now, this scenario can also hold true if you have -1 to the -4. That's also an even number. 4 is even. -4 is even, I think. So we've got 1 over -1 to the 4, and therefore that is also 1 over 1, which is 1. Okay? So those are 2 possible choices for my A and my B. All right? And now I've got to go and figure out what is it for C and D. Okay, first let's start with this guy here. Let's keep those 2 for my A and B. Now what numbers do I have left over? If I've already taken out a -1 and -2 from this list, I've got -3, -4, and -5 remaining. Now you might say, well, that's still a lot of answer choices, a lot of combinations. I don't want to go through all of them. And the good news is you don't have to. Again, you choose an exponent that is even for the same reason, because you want a positive answer. So there you go. Now I just have to do this twice, once for -3 and then once again for -5. So let's just do it for -3. That will be -3 over 4. And this looks like -3 to the power of 4 is 81. So this will be, if you add 1 plus 1 over 81, that looks like 82 over 81. So let's do the same scenario, but this time we're going to use -4, of course, but we're going to use -5. That's the only other choice. So this becomes 1, and this becomes 1 over -5 to the power of 4, and that is 1 plus 1 over 625, and if you do the math here, you get 626 over 625. Okay, now that we got the hang of it, we can probably do the remainder pretty quickly. I think there's only 2 other choices. In this one where you have -1 and -4, remember the exponent has got to be a even number. So -2 is the only other possibility. And therefore I've got -3, and then the other one, of course, would be -5 to the exponent -2. Okay? All right, let's figure this out. So this is going to be -3 all squared, and that looks like 1 over 9, and therefore that makes this 10 over 9. And then this one will be 1 plus 1 over -5 squared. So that is 1 plus 1 over 25, and that is 26 over 25. So there you go. Those are the answer choices. Now, which one of these is the largest? I'll just convert them to decimals, and that will help me a little bit better. And those are going to be 1.0016, 1.01, 1.11, and 1.04. And of those, the largest is 10 over 9. So number 21, the answer is D. In the diagram, a semicircle has diameter xy. Rectangle PQRS is inscribed in the semicircle with PQ equal to 12 and QR equal to 28. Square STUV has T on RS, U on semicircle, and V on XY. The area of STUV is closest to. So this diagram, I blew it up a little bit. Here is the center point approximately of the semicircle. I'm going to draw a line from that center point to the corner. So point Q like that. And that, of course, represents the radius. I'm going to do the exact same thing, but this time, instead of Q, I'm drawing it to U. Letter U. And I think that's about it in terms of lines. I don't think I need any more lines. Now I'll start labeling values. So PQ, they tell me in the question, is 12. And then QR, they tell me, is 28. Right? QR, this distance is 28. And did they tell me anything else? No, they don't. That's it. Okay. No problem. I think I should be able to figure this out. Well, let's see here. I said I wouldn't need to draw any more lines, but I think I'll draw just one more. A line from the center all the way to the top like that. And the only reason I did that is because that chops QR into halves. Okay? So that means this is 14 and this is 14. And very similarly, since PQRS is a rectangle, this is 14 from here to here, and this is 14 from there to there. All right? Okay. All right, I think this should be pretty straightforward. Just use Pythagoras. This distance right here is the radius, so I'll label that R, radius of that semicircle. So using Pythagoras right here on that triangle, Q, P, and whatever that is, we can get a relationship for R. R squared is equal to 12 squared plus 144, plus 14 squared. And that would be 144, I got ahead of myself, plus 196, and therefore R squared looks like 340. All right? And then our next Pythagorean relationship is going to be on this guy, that triangle right there. I'm going to label something from S to V, I'm going to label that X. And since they tell you that the STUV, this shape, is a square, then that means that U to V right there, that's also going to be X for obvious reasons, since sides of a square are the same. All right, let's use Pythagoras on that triangle now. So that gives me, let's see here, 14 plus X all squared plus X squared is equal to R squared, because this green line is the radius. R squared is 340. We just figured that out upstairs. And now we have to do this math here. So we've got x squared plus 28x plus 14 squared, which is 196, plus x squared. So that gives me 2x squared plus 28x, 196 minus 340, which is negative 144, is all equal to 0. I think I can factor out a 2 here. That gives me x squared plus 14x minus 72 equals 0. And I think this should factor. X, 18, and 4 positive, negative? Yeah, positive, negative. That will do it. So this gives me x is equal to either negative 18 or positive 4. Well, obviously x is a distance, so it can't be negative 18. So x can only be positive 4. Now they want you to figure out the area of STUV. No problem. Area of that squared is x squared. And x is 4, so it's 4 squared. And therefore the answer is 16. So number 22, the answer is C. A solid cube of side length 4 centimeters is cut into 2 pieces by a plane that passed through the midpoints of 6 edges as shown. To the nearest square centimeter, the surface area of each half cube created is. So here is a diagram that illustrates what is happening. You've got this plane that chops or slices this cube into 2 parts. And they want you to figure out the surface area of each of these half cubes. Well, this diagram shows you that when you slice it like that, you get 2 shapes that are essentially identical. Now, you have to understand how many sides does each of these shapes have. Well, this diagram shows you there's 1, 2, 3, 4, and then this diagram is basically the other side. So a 5th, a 6th, and a 7th. 7 sides. So that is the first part of this question to understand. When the cube is sliced, each half cube will have 7 sides. And you'll notice that this part right here is the hexagon. So that is part of understanding this question conceptually. Now, because of the symmetry, when you chop this into half, the surface area of the half cube is also half, all right? Not counting this side. That's something new that we've introduced because of the slice. But if you don't count that hexagonal part of the half cube, all the other sides will have a surface area half that of the original cube. Because of symmetry, the 6 other sides or faces have a surface area that is half the surface area of the original cube. And that surface area would be half of the original surface area. The original cube, of course, has 6 faces. Each face has an area of 4 times 4, right? Because the question tells you that each side of the cube is 4 in length. And that looks like 3 times 16, which is 48. All right, so we've taken care of 6 sides of that half cube. All we have to do is figure out the surface area of that slice area, and then we can add that to 48, and we'll be done with the question. The 7th side is a hexagon. So if we can figure out the area of this hexagon, we're all set. So I'm going to split this up into different sections, and then it'll just make it easy for me to figure out the area. Now the first thing is I've got to figure out the side length of this hexagon. And how do I do that? Well, I'll go back to the original. Here is the side length, right, from there to there. And that is a triangle that is obviously a Pythagorean relationship. This little guy right here. And we know the sides are 4. So this whole thing is 4. They tell you that in the question. So that means this is 2, because they tell you that it's the midpoints that this plane passes through. So that's 2 and that's 2. And this is, of course, a square, so that's got to be a right angle. So to figure out that side of the hexagon, it's just the Pythagorean relationship. 2 squared plus 2 squared is equal to, I'll just call that x squared, and therefore x squared is equal to 8, and x is equal to root 8. So there you go. very quickly, we got this to be root 8. All right, and now let's do one more cut here, all the way across like that. And this will help me now figure out the area. Now, very quickly, I want you to remember that the sum of the angles of a hexagon are 720. Now, even if you didn't remember that, you can just split this up into triangles. And it's 1, 2, 3, 4 triangles. 4 triangles, 180 times 4 is 720. And therefore, each of these angles, each of these interior angles, there's 1, 2, 3, 4, 5, 6 of them, is going to be equal to 720 over 6. And that is equal to 120. So this is 120 degrees. Now, if this is a right angle, then that means this has got to be 30 degrees. And this is a right angle, so therefore this is 60. And all the sides are root 8, like that. So there you go. We again have this famous 30, 60, 90 triangle that seems to keep popping up again and again on math contests. And I'll just draw it on the side here to avoid making this messy. So we've got 60, 30, and this always has the following ratio to the sides. 30 side opposite of it is 1. The right angle side opposite of that is 2. And opposite of 60 degrees is 3. This is the ratio of the sides. Now we know the actual length of one of these sides is root 8, and therefore the actual length of this side will be root 8 over 2. And then the actual length of that side will be root 3 times root 8 over 2. All right, and there we go. We got enough to figure out the area of the shape now. This here, we just figured out, was root 3 times root 8 over 2. And this here, that length is root 8 over 2, like that. Okay, so the first is this big rectangle, if I want to figure out my area. And that's length times width, so we got root 8 times this guy times 2. So that would just be root 3 times root 8, like that. And then I've got to add to that these triangles. And there's 4 of them that are identical, right? And 2 on the other side. So 4 times 1/2 base, which is root 8 over 2, times height, which is root 3 times root 8 over 2. So this looks like 8 root 3. And this looks like, let's see here, 8 root 3 over 2. So this looks like 3 over 2, 8 root 3. And if you get out your calculator, that will be 20.78. All right. Remember before we got 48, that was the surface area of 6 of the sides. The 6 sides. And then the shape had 7 sides, and that 7th shape was our hexagon. And we got, for the hexagon, 20.78. So now we just have to add this 48 to this 20.78 to get the total surface area of that half cube. And that would be 48 plus 20.78. And that is equal to approximately 68.78. 68.78. So we have to figure out which of the answer choices this is closest to. 68.78. To the nearest square centimeter, the surface area of each half cube is. That would be choice A, that it's nearest to. So number 23 is A. The arithmetic sequence a plus d, a plus 2d, a plus 3d, a plus n minus 1d has the following properties. When the first, third, and fifth, and so on terms are added, up to and including the last term, the sum is 320. When the first, fourth, seventh, and so on terms are added, up to and including the last term, the sum is 224. What is the sum of the whole sequence? So we have a plus d, a plus 2d, and so on, a plus 3d, all the way up until we get to the final term, which is a plus n minus 1d. And this has n terms. We don't know the value of n, so we have to make some decisions later on as to what n could be in terms of being even, being odd, divisible by 2, divisible by 3, and so on. Now, we are going to first, let's look at the first criteria, that the sum of the first, third, fifth, and so on, including the last term, have to add up to 320. All right? That basically means that a is the first term, the third term, what is a plus 2d, the fifth term, a plus 4d, and then I guess they're hopping over 2. So a plus 6d, a plus 8d, and so on. All the way up to and including the last term, which is a plus n minus 1d. And there you're saying that is equal to 320, that sum. All right. We have to make a decision here as to what is n. We don't know the value for n. We don't know what it is, how many terms there are in this arithmetic sequence. They have not told us that. But in order to get some sort of a relationship, we've got to make a decision as to what it is. Is it going to be odd, even, divisible by 2, divisible by 3, and so on? So I'm going to say that n minus 1 is even. Okay? Now, if I'm wrong, I can always change my decision later, but I've got to start somewhere. So if n minus 1 is even, that means n is odd. Okay? So now let's sum this all up. This is going to be, how many a's do we have? Well, we've got n minus 1 right here. We've got to divide that by 2, and we've got to add 1 to it. And that's how many a's you have. And then these 2d's, 4d's, 6d's, something can factor out from all of those. We can factor out a 2d. And if you do, you get 1 plus 2 plus 3 plus 4 plus ... all the way until n minus 1 over 2. And this is all equal to 320. Okay? So let's keep going here. This becomes n plus 1 over 2, if you do the math there, a plus 2d. This whole thing, as I'm sure you know, if you add up consecutive numbers, 1 plus 2 plus 3, all the way up until n, that is equal to n times n plus 1 over 2. So using that formula, this becomes n minus 1 over 2 times n minus 1 over 2 plus 1 all over 2 is equal to 320. All right, so let's just keep going here. We got to simplify this expression now. This one stays the same, n plus 1 over 2 times a. And this one becomes n minus 1 over 2 times n plus 1 over 2. And then I'll just bring the half out front like that. And at this point, I think I can just factor out an n plus 1 over 2. And if I do that, I'll have a plus 2d times n minus 1 all over 4 and that is equal to 320. And I will call this equation 1. All right, that's about as far as I can go there. Now we need to look at the second criteria right here. The first, fourth, seventh, and so on terms are added up to and including the last term. That sum is 224. All right. So the first and then the fourth term and then the seventh term and so on, the 10th term, are all added up to and including the last term, which is a plus n minus 1d, like that. And that is all equal to 224. Okay, now again, we have to start making a decision here as to what n can be, because we don't know. So to make this work in a way that I can add it all up, I will let n minus 1 be even, just as I did previously, because I have to be consistent. But this time it's not as simple. I also have to let n minus 1 be divisible by 3. And that's the only way I'll be able to add these in a way that will give me one solid equation at the end. All right? So for example, if you're kind of wondering this to be a little bit more abstract than you had hoped, a value that would work is n minus 1 equal to 12. N minus 1 equals 12 makes that even and divisible by 3. Okay, so let's go with that. This is just an example, by the way. All right, so here we go. Let's add all this up. So again, we get how many a's? N minus 1 divided by 3 plus 1, a. And then from all of those, you can factor out a 3d, and you'd get 1 plus 2 plus 3 plus ... all the way until you get to n minus 1 over 3. And that is all equal to 224. So simplifying, this becomes n plus 2 over 3, a, plus 3d, and if you use that fancy formula, you get n minus 1 over 3 times n minus 1 over 3 plus 1 all over 2. This becomes n plus 2 over 3 times a plus 3d n minus 1 over 3 times n plus 2 over 3, and we've got this a half. And I think I can factor out at n plus 2 over 3, and that would give me a plus 3d times n minus 1 over 6 is equal to 224. And I'll call that equation 2. Now, since we have looked at the two criteria, let's look at the entire whole sequence. A plus D plus A plus 2D, and so on, all the way up until the very last term, which is A plus n minus 1D. And let's add all of that up. So this is going to be n times A plus, factor out a D, and you get 1 plus 2 plus 3 plus ... all the way up until n minus 1, like that. And then this will be n times A plus D times n minus 1 times n minus 1 plus 1 all over 2. And this looks like n times A plus D times n minus 1 times n all over 2. And factoring out an n, you get A plus D times n minus 1 over 2. And there you have it. This is the sum of all the terms, the entire sequence, the whole sequence. So let's summarize our findings. Equation 1, equation 2, and the total sum. So these are my findings that I have figured out thus far, and the hope is that it will help me figure out a numerical value for the total sum. All right, now let's remind what my criteria was. I stated that n minus 1 had to be even, and that n minus 1 had to be divisible by 3. All right, let's start plugging in numbers. What kind of numbers do you want to use for n here? Let's take a look. Let's look at this and see if anything comes to mind here. We got 3D, 6D, 9D. Just brainstorming. I think I'm going to first start with n equal to 13. Why? Because if I do that, n minus 1 will be 12, and that meets both of my criteria. It's even and it's divisible by 3. Let's see what we get for equation 1 and for equation 2. For equation 1, that will give me 13 plus 1 over 2, a plus 2d, 13 minus 1 over 4 is equal to 320. And that gives me 7 times a plus 2d times 3. And that gives me 7a plus 42d is equal to 320. And if I divide by 7, I'll get a plus 6d is equal to approximately 45.7. All right. How about equation 2? What will I get using n equals 13? Okay, we got 13 plus 2 this time, divided by 3. A plus 3d, and I've got 13 minus 1 over 6 is equal to 224. All right, that looks like a 5a plus 3d times 2 is equal to 224. And that looks like 5a plus 30d, if you multiply this all out, is 224. If I factor out a 5 or divide through by 5, I get a plus 6d is equal to 44.8. Oh boy, that doesn't work. A plus 6d is 45 there. A plus 6d is 44. Okay, that means that this is not right. No problem. Let's keep going. Let's get another number for n that's even and divisible by 3. Let's just go up to the next one, which I believe would be 19. That would make n minus 1 18, and 18 is indeed even and is also divisible by 3. All right, let's do this again. So equation 1 here, this time becomes 10, correct? I'm just substituting 19 for n. 10 times a plus 2d, 18 over 4 is equal to 320. And that looks like 10a plus 90d is equal to 320. And divide through by a 10, we'll get a plus 9d is equal to 32. Okay, let's plug in n equals 19 into that second formula. That looks like it will give me 7 a plus 3d times 3 is equal to 224. This looks like 7a plus 63d is equal to 224. Divide through by 7, you get a plus 9d is equal to 32. All right, perfect. We got it. Both of those match. So n is indeed 19. Great. Now I can use that to figure out my total sum. So let's move this up a bit. Total sum is n is 19, and then we've got a plus d, 19 minus 1 over 2, like that. And this is 19 times a, that looks like 18 over 2, which is 9, so 9d. Well, a plus 9d, we just figured out, was 32. So that's 19 times 32. And if you do that multiplication, you get 608. So there you go. That's the answer. The answer, therefore, to number 24 is 608, which is choice C. A triline is a line with the property that 3 times its slope is equal to the sum of its x-intercept and y-intercept. For how many integers q with 1 less than or equal to q less than or equal to 10,000 is there at least one positive integer, p, so that there is exactly one triline through pq. So all lines are of the form y equals mx plus b. And how do we find the slope? Well, the slope is right there. It's m. And they tell you that 3 times the slope is equal to the sum of the x-intercept plus the y-intercept. So let's figure out the x-intercept and the y-intercept. To get the x-intercept, of course, you set y equal to 0. So that would mean 0 is equal to mx plus b. And therefore, mx equals minus b. X is equal to minus b over m. This is my x-intercept. So minus b over m. And now the y-intercept I will get by setting x equal to 0. And therefore, y is just going to be x, which is 0, times m plus b. And therefore, y is b. That's my y-intercept. So there you go. This is my formula. And if I take that formula and simplify it a little bit, let's see, we got 3m equals minus b over m plus b. Let's add a fraction here, top and bottom by m. And this becomes 3m is equal to mb minus b over m. Multiply the m to the other side, cross multiply, and then factor out the b, you get m minus 1. And therefore b, if you isolate for it, will be 3m squared over m minus 1. All right? So substituting back into there, we have y is equal to mx plus b, which is 3m squared over m minus 1. All right, so that is our equation of the line. Now, they tell you that there's a point PQ that is on this line. So let's substitute that in. We've got Q as our value for y, and we have P as our value for x, plus 3m squared over m minus 1. All right, so far so good. No tricks, no magic here, just straightforward. Now, what I want to do is I want to isolate for P, because they want us to concentrate on trying to figure out P and Q. So I've got to isolate for at least one of those variables. So let's do that. So we've got Q minus 3m squared over m minus 1 is equal to MP. This looks like we can multiply top and bottom by m minus 1 to get this additional. And this will be Q times m minus 1 minus 3m squared all over m minus 1. And I'll just bring this m down here. And there you go. I've isolated for P. Now, they want you to figure out integer values for P. for q being between 1 and 10,000. So they're saying for all of these integers between 1 and 10,000 inclusive, we want you to figure out values for p that are also positive integers. So how do we do that? Well, since this is an equation, looks like it's most likely a quadratic equation, let's make it into that kind of a form. Because in this form, I don't think it will be that easy to figure out individual values for p. It doesn't give us any real help. Nothing really cancels like I had hoped it would. So no problem. We'll just keep going in another direction here, which is trying to figure out this in the form of a quadratic. Okay, so let's do that. We've got 3m squared plus qm minus q is equal to p times m squared minus m. So this becomes pm squared minus pm minus 3m squared plus qm minus q. And then we have minus 3m squared collecting like terms. Bring everything over. Minus pm squared plus qm plus pm minus q is equal to 0. If I multiply through by -1, I think this will be a little bit better. Pm squared minus qm minus pm plus q is equal to 0. All right, so this looks like a little bit better in terms of a quadratic. So I've got 3 plus p. There's my coefficient in front of m squared. And then in terms of the coefficient in front of m, it looks like it'll be minus q plus p. And then I've got this lone q out front. All right, great. So it's in the form of a quadratic equation. Now, let's go back and read the question a little carefully once more. For how many integers q, with q between 1 and 10,000, is there at least one positive integer p, so that there is exactly one triline through pq? What does that mean? It means that you want exactly one point pq going through that line. That's it, just one. And the only way that can happen is if our quadratic equation has only one solution. Not two, but one. Exactly one pq means that there is only one solution to this quadratic equation. And this occurs when the discriminant equals 0. So what is the discriminant in this quadratic equation? Discriminant is of the form b squared minus 4ac, and we have to set that equal to 0. So using our coefficients in this quadratic, that would be minus q plus p all squared minus 4, 3 plus p times q, and that equals 0. All right, so let's solve for this. We've got q squared plus 2qp plus p squared minus 4q times 3, which would be 12q, and then minus 4 times q times p, which would be minus 4qp, is equal to 0. All right. Let's see if we can collect any like terms here. Q squared 2qp plus p squared, and I'll put the 12q over to the other side because it doesn't seem like it groups well, because this groups perfectly. It just factors into q minus p squared. All right, so I've got q minus p squared equals 12q. And we know that q is between 10,000 and 1. So how do we figure out what are our possible values for q? Well, 12q has to be a perfect square. That's what this side is. The left side is a perfect square. So q minus p squared is a perfect square, obviously, and 12q therefore must be a perfect square. Well, 12 is already equal to 4 times 3, correct? And 4 is already a perfect square. It's 2 squared. So that means we've got 2 squared times 3 times q. So this is already a perfect square, so I've got to now concentrate on this. This has to be a perfect square, this 3 times q. Now, how can that happen? It can happen if q is of the form 3 times some perfect square. That would make this entire expression a perfect square. 2 squared times 3 squared times k squared. All right, so that basically means that q must be of the form 3k squared. All right, no problem. Let's go back to this equation or equality. Q, I'm saying, is of the form 3k squared, and that is between 10,000 and 1. Divide everything by 3, and I've got 1/3 is less than or equal to k squared is less than equal to 3 approximately. Take the square root of both sides, and that would give me about 57.7 is greater than or equal to the square root of 1/3. All right, so that means k, since k is an integer, that's the only way we can get q to be an integer. K has to be 1, 2, 3, 4, all the way up until 57. That's the only way. And therefore, for each value of k, you'll get a corresponding value of q. Therefore, q will have 57 values. One value for each of the 57 values of k. So therefore, the answer to number 25 is 57, which is choice B.